Yeah, Max and Sven, representing Bosch in this case and also the University of Leipzig. And I think the bold question that we want to go into the next couple of minutes is, what makes an open source project sustainable? I mean, the question what sustainability means is a bit beyond the scope, but we can all agree that when we build projects, we often end up in a situation where we have a supply chain which is not completely in our control. So more the technical side would be, even though I have a project, I might have a sub dependency, project alpha, which has an issue. It might be a security problem, might be a license change, might be that the maintainer is stopping the maintenance for whatever reasons, maybe because they become underfunded. And obviously this propagates into your project. And I think this is quite recent because we've seen quite a few supply chain attacks in the past which actually attack on this vector. The more meme side of things is here. I think everyone has seen this already. If you're a bit in the industry, is this famous XKCD. So the whole digital infrastructure looks like this, but we really looking forward for what is this particular stone which everything else is built on. So where are the random dudes in Nebraska and where are these random projects that are really important for the infrastructure? This problem has become quite relevant also during the time of our research, as you can see by all these different news articles. So some people already said that March 26th, which is just last month, was a very bad month for supply chain attacks. So we had a lot of attacks basically somehow originating or attacking the maintainer, and then this propagated to the whole supply chain. For instance, one example, just as we are in Brussels, was the European Union. So Europe.eu lost 350 gigabytes of data because one of their security scanners actually got compromised, which then had access to a lot of their secrets and infrastructure. So you see this problem is not just bound to a particular project or one open source project, it really propagates. Another problem is, as we have seen with Log4j, which was a couple of years ago, that fixing the problem was actually quite easy, but upgrading the software that relied on this dependency was quite hard. So many organizations had big problems or were struggling with upgrading that and was actually incurring a lot more cost compared to the actual fix in that case. So what we then argue for is if you see the open source ecosystem as an ecosystem as it is, and maybe as forest, which is also an ecosystem, the idea is, okay, how do we find the project or the trees or the members of the community that might be in struggle, that might be in need of support to really have a more sustainable ecosystem here, and also proactively find those in your supply chain before it becomes too late or it is already shipped in your own projects. And if you look into the communities, obviously we're not the first ones to have this problem or deal with this idea. So there are way other communities. So the most famous, I would say, and sorry, it's Eclipse event, it's the Linux Foundation activity, it's the Chaos community, which has a lot of properties on evaluating the community health or the community risk for a project. There's also the OpenSSF project, more looking into security. It's more the security angle for the supply chain, which also has their scorecard project, which you can basically run an automated scanner through your project and see like how it is judged. One problem that we've seen with those kind of ideas is it's more an opinionated or well-educated, let's say, guess by most of the community, and I'm not saying this in a bad way, because it's more, okay, we say, yeah, a project is better if it has more maintainers, which might be in general maybe true, maybe not, but we could definitely make examples where more maintainers was even worse. Let's take XZ, for instance, where there was a maintainer coming in and actually worked against the project. So what we had as an ambition was to really look into the actual data from the past, to kind of mine data from projects or metadata that we had, to see what are the actual leading indicators for problems that occurred later in those projects. So really go a long way with the data. And the vision somehow was, okay, let's start with SBOMs. So when you take your own project, you obviously have the chance to create an SBOM. How this looks like is a completely different story, but let's assume we have one. Then you try to collect a lot of data, also historic data about the project, and basically do magic. And this is kind of what the research is doing now. Okay, fill this magic, like pre-process the data, come up with a model, and then out of this model have some kind of report which explains you the criticality or the confidence that you have in this particular project. And this is exactly what Max has been doing in the last couple of months, and he will tell you what and how he did it.
All right, so before we do some actual data crunching, we need to think about which projects we actually want to look at. And in other terms, we need to think about how our population will look like. And common way of doing this in research is to use some form of popularity-based metrics, like monthly or weekly downloads and stuff like that, or GitHub stars, which is the one we end up using. And the reason for that is that we think that these projects tend to represent the projects which are in real-world SBOMs. And for that, we looked at 15,000 projects, the 15,000 most starred projects on GitHub. And now's the question, how do we get the actual projects for this population? And GitHub, or the GitHub search, is not that open about, for example, 15,000 projects. So at this time, I stumbled upon a blog post by the ClickHouse database project. And what these guys did is they provided a public instance of the database and of the GitHub archive dataset. And it's actually the largest dataset of GitHub interactions data. And we can use that to query the dataset and get our projects. But it turns out, when we look at these projects, huge amount of projects are non-software repositories. So, for example, system design primers or coding interview questions, stuff like that, and books and projects written in niche languages. We are especially interested in real software projects, not software-related projects, right? So we have to filter out these ones. We did some systematic literature study to get signals which represent open source project health, and came up with a list of 39 indicators, which basically can be grouped into the following dimensions. Repository metadata like licensing and the language the project is written in. Of course, development activity data, organizational data like GitHub's community health score, which basically represents the presence of different files like contributing files and stuff like this. Of course, software is developed by individuals, so we are interested in community and engagement of this community. Risk is also a factor like DDS scores, development distribution score, similar to truck or bus factor. We are interested in open CVEs, and of course, popularity and adoption. Now that we have some form of population, we can look into how do we actually get the data for these repositories. And besides, obviously, GitHub, which provides us with activity-related data, commits, issues, releases, and stuff like that, we have different, I would say, platforms like ecosystems and open source insights, which we ended up using. And these platforms kind of act like aggregators, not only aggregators, but mostly as aggregators for these package registries like Crates.io, Maven Central, NPM, etc. And using that, we can get more package metadata and community signals, and especially for open source insights, we get a dependency graph, list of dependent projects, licensing data, etc. For security-related data, there's a project called OSV. It's a database which also acts like an aggregator for multiple vulnerability datasets, like the one GitHub is publishing, or RustSec, PyPI, etc. Now we can get into collecting our data, right? So we took a small subset of our 15,000 most start repositories. We took 1,700 repositories and wrote a collection pipeline in Golang to collect all the information I was talking about earlier. So all the static and time series based data for a 24-month period. So the period starts in March 2024 and ends in March this year. Of course, this doesn't come without its challenges worth talking about. And the first one is the construction of PURLs. So PURLs are these tiny little package URLs representing a package, its ecosystem it's located in, and a versioning number, and some other things. But the cool thing about PURLs is that once we know that a repository is building a package and have a corresponding PURL, we can use this as an identifier for all sorts of platforms, like the ones I showed earlier. The problem here is that, of course, we are looking at repositories, not packages, and there's, of course, no standardized mapping between these two. And therefore, the PURL derivation can become quite cumbersome. But the way we overcame this challenge is that we looked at the code. So we scanned their manifest files, like the one package JSON file, like the one npm uses, or for Composer and the cargo toml, etc. And we look for names, versions, the ecosystem, of course, and therefore can infer the PURL and check ecosystems against this PURL. Another challenge is, of course, licensing information. Turns out, huge chunk of these repositories we are looking at are not representing their licenses in a standardized way. Quite common problem. But there are some platforms or projects which are better suited for getting licensing information than GitHub. So the problem is, if you, for example, this C project, if you present your licenses in a non-standard way or have directories licensing under different license than others, the GitHub crawler have a hard time on inferring the right license. A third challenge is that the GitHub stars might be a bad proxy for popularity. And there's actually ongoing research on that. And what these researchers basically say is that GitHub stars might be at risk at being artificially inflated. So projects, mainly because of malicious reasons, use these stars to place their projects in databases or searches and to get basically more attention. It's famously are some crypto projects, but the research project actually provided a data set which we checked against, and there's no overlap between our data and the malicious projects they found. Another thing is that, as you can see in the image on the right, there's actually a big spike in 2024, late 2024, and most of the projects we have looked into are older than that. All right, so we have our population, and we have the platforms holding all the information we need. We built a collector, and now we want to walk more towards the vision Sven showed in the beginning. And we somehow want to classify these components. But speaking of classification, so normally for classification tasks, you need some form of target variable or label, something like that. The problem here is that we actually don't know how to construct these labels, or we don't even know how these labels can look like, or which is a suitable label for representing these risks. So we use clustering to identify groups of similar open source projects and discovered categories based on these characteristics they show. And then we looked at these clusters, analyzed them, and analyzed what properties define these clusters. Of course, before we can do some data analytics, we have to do some pre-processing. I don't want to go into much detail here, but as Sven said in the beginning, we are mostly interested in the evolution of projects over time. So time series-based data is of special interest for us. Therefore, we calculate the trends of our longitudinal data. We created month-specific features for features like commits over time and releases, and how many people interacted for inside issues via comments and stuff like that. We did some encoding of our variables, scaled the data and transformed it, and employed or removed highly correlated features. Using that, we can build models, right? And as I said, we want to use clustering for that. And there's a common pipeline in research which is composed of dimensional reduction via UMAP and clustering with HTTP scan. UMAP is basically a dimensional reduction algorithm which you can use to project high dimensional data, which we end up having into lower dimensional embeddings. And this is practical for clustering. Speaking of clustering, we use HTTP scan to cluster the projects, and HTTP scan is a neat clustering algorithm because you don't have to specify an amount of clusters you want to get. And that's good for us because we don't know how many target variables there are or how these labels look like, right? Another thing is it builds a noise cluster, and real-world data often is very noisy, right? So as it is for our open source projects, and it turned out to be pretty useful. What we ended up is having 5, we call them archetypes, for the projects we analyze. We tried to generate some small images to make them more feasible. So the first cluster which emerged are, we call them flagship projects. These are the ones having the lowest risk. They have relatively large communities, active communities. They have multiple contributors or maintainers. Some of them have corporate involvement, and they tend to have very mature project structures. The second one, we call them resource-constrained peripheral projects. These ones are much smaller. They have higher risk because they are maintained by only a few maintainers or just one. They have no mature project structures and rather small communities. The third one, critical infrastructure with concentrated ownership. As the name suggests, these are projects tend to have a large amount of dependent projects. Also, they tend to have medium-sized communities or small-sized communities and face high risk because they only have one maintainer. And that's a huge problem, especially if you think about the number of dependents they have. So they sort of sit like critical infrastructure. The fourth one are declining mid-scale projects, and these ones, they are moderate in every sense. So they have medium-sized communities. They tend to have a medium response times to issues and communication. they have medium-sized governance and resources, and so they're moderate in every dimension. The fifth and last one are the capacity-constrained mature projects, and they are low in risk because they have some maintainers left and have quite mature structures. The problem they're facing is that their development activity is actually declining. But as I said, they're mostly projects which are medium-sized in a sense that they were popular at the time, but are declining now. So a question is, how do these clusters emerge? And clustering generally is considered hard to interpret, and we use a technique called CHAP, and we can use this one to basically train a classifier on these clusters and look how valuable each of these features is that we use, and we try to find key differentiation features. And this has basically two objectives. The first one is that it allows for cluster interpretation, and the second one is we end up having a couple of variables which are strong in predicting these clusters, and we can use that to build classification models using these variables. Speaking of primary predictive variables, interesting is that the primary drivers for the clusters are licensing and community-related files. Those ones had the highest impact. So if the project has contributing guidelines, if the license is known for a project, if it has external documentation. Secondary drivers are contributor counts and the trend-based metrics I was talking about earlier. The lowest impact for these clusters are the committer counts and active maintainers and pull request response times, and some specific templates like PR, pull request templates, and code of conducts. All right, so what do we have at hand? Of course, we have SBOMs, plenty of SBOMs, and we talked about the data collection process using OSV, GitHub, ecosystems, and all these platforms. We briefly talked about pre-processing, so how can we calculate trends on these time series-based data and how we can prepare our features. We built basically two models. So the first one being the clusters which we identified, and the second one we used CHAP to determine primary variables which have high impact on these clusters. And we can use that to build classification models, right? We can basically use any arbitrary classification algorithm for classifying that as long as it has enough capacity. And we use XGBoost for that. It's quite common and considered state-of-the-art for classification. And by using that, we can, as Sven said, generate reports. So we shove in SBOMs, and at the other side, we get reports of all these components classified by risk. All right. So we tested this in action on a project Sven is involved.
Sure. So maybe coming back to that slide. As you've seen, we came up with a model now. So we have the tooling that we envisioned after a couple of months of working in data crunching. And the question is now, where do we go from here? Like, we have the tool, but let's use it. So one example is we have the Cookser project. It's Eclipse Cookser, to be more precise. It's a growing project in the Eclipse Foundation from the SDV ecosystem. And it's mostly about doing vehicle abstraction, so decoupling applications from the vehicles. So for this talk, it's not really important what it does, but it's a Rust project. It has a couple of lines of code. And I think the most important feature is it has 546 packages it depends on. So the SBOM is large, but maybe not too large. And we just put this SBOM through the tool, and I think the findings were quite interesting because we had 7 features or projects that were critical infrastructure, and we had another 24 which were of these resource-constrained peripheral projects. What this means for us is out of the 546 packages, we have 31 where we might or should take a look at, because here we consider being in one of these 2 clusters as being a high risk, while for instance for the flagship projects we don't see too much risk. So at least just looking by the data, there it's more fine. So now we have the data, but what do we do with that? It's always the second question. Or maybe it should be the first. One thing, more from your personal opinion or standpoint, is you select projects maybe based on these findings. Let's say you have 3 projects you can select from, and then you can run some number crunching and some of the model and see, okay, maybe this project has way more credibility or less security issues in the past, so let's go for that one. Another thing is risk monitoring over time. Let's say you have the project, or might even some of these projects also in the field, so that you can constantly look into the data from your SBOM when you ship the project and reevaluate whether there have been problems or whether you might expect problems before they occur. Because again, if you do this more proactively, you have a way better way to react. Speaking of reaction, another thing, and that's also I'm really curious to hear your input also from the in the room, is it also can help to distribute support more effectively. Because coming back to this analogy with the open source ecosystem being a forest or a whole garden, it's a good way to actually at least identify where you might have problems in the future and then distribute the resources. But most importantly, and that's also part of the reason we did this talk, is we're really interested in your use cases. So having this number and also these clusters at hand, I would be really curious to hear, like, what would you do with that? Or is there a good tool to put this in? You've already thought about a couple of tools which deal with SBOMs and also compliance where this could be added. So I'm happy for these conversations. About exactly these kind of questions, like, what do you think about the approach? Is it pure nonsense? Is it too opinionated? Does it make any sense? Would you like to collaborate on? That's also something that we currently consider. How do we continue? Because it has been more on the academic research side so far, but I think it's also open for collaboration, or maybe you've done similar things. We already talked to some universities which have a similar database in place, so I think there's room to grow this together. Then a very important question, and I think that's also more something we can have in a personal conversation, is if you follow the talk closely, you might wonder, we haven't said any project by name yet. And we did this by choice because we wanted to avoid such like a data-backed blame game. Like someone saying, hey, they said your project is bad because of that and that. And I think it's still quite opinionated in a sense that in your particular situation, these numbers might add up to the situation that you end up in one of these clusters, but it's just a, let's say, very generalized overview, not that to consider every individual case. That's why we are very cautious with naming particular projects. And I'm wondering whether I'm a bit too cautious here, but yeah, that's the thing. Another question, Max already pointed it out. We basically use the clustering to find out what is a good indicator for a good project, because good and bad already is quite opinionated. Is it the number of CVEs? I would say not, because if your project is not well maintained, you won't have any CVEs, but you're a perfect project. Not sure about that. So that's also where we come back to these communities like Chaos, for instance. And last but not least, and again, this could be also a good way of finding projects in need of support. So what does having such clusters or such research mean for setting up OSS funding mechanisms, like the Sovereign Tech Agency that was set up in Germany. And maybe a funny side story to that is we talked to people that did similar research, and this was exactly the reason why they got funded, because the funding agencies wanted to know whether the other funding for other open source project was actually successful, so they needed someone to evaluate that, and this resulted in a research about metrics or health indicators for open source projects. This runs through the data. We are very happy that you're still at least physically in the room and are here. And looking forward to your questions, discussions, and input. There was one hand raised before.
Yeah, exactly, but you
Yes.
already more or less answered that because it's today that you don't want to start the blame game. I was asking actually for good examples, like for example, I was thinking of something like PURL. I guess everyone's listening.
I think it's for the registration.
For the recording.
Okay, sorry, then I will just reiterate my question. So more or less you already answered it. I was thinking about whether there are good examples for the archetypes, but you stated that you don't want to start the blame game. I was just curious about examples like where to put Kubernetes. I guess that's very obvious. Maybe also curl. That was one of the points. And after you've put your example, maybe one question. So in the SBOM case, how deep do you go to assess that? Just single level SBOM or really deep until there's no more dependency? Because sometimes it will get cyclic or something like that.
Right. So in the case of the Eclipse Cuxa data broker, we just got the SBOM from GitHub, and I think there are around 500 to 600 dependencies there. So it should be transitive dependencies.
So the full dependency tree, not just the first layer.
Yes.
Yeah. But I mean, for the tool itself, or what he's been building is, I would say it's quite agnostic, because it basically takes the project and then evaluates each project on itself, not taking the context whether it's like the third, fourth, or first layer in your tree. So
yeah.
And what we also don't evaluate so much is like how the project is actually used. It's more like a binary. Okay, the project is in your SBOM. What you actually do with that, it's I think part of another observation or an analysis.
I mean, there's tooling for that in front of this whole tool chain for regarding SBOMs. So.
Maybe one further question regarding that. So you more or less have like the dependency direction into one way, right? So do you also evaluate in your model or clustering the other direction? So for example, I have a project. How often is this project used? Because that will also be interesting in case I'm a maintainer and I would like, for example, thinking of making it a business model, for example, and then I can evaluate if there would be a direction for me. So if I, for example, am the maintainer of curl, and I could evaluate how many persons are using curl, also via this SBOM metric. Or maybe very specific also and complex in getting that.
I mean, for the clustering, it's I would say not the main goal to figure that out. There is in some case data available. So for instance, GitHub, if they have the SBOM for a project, they also provide you a means to let you know who's using your project in their SBOM, which is already a good indicator, but obviously this doesn't tell you anything about closed source adoption of the project. So it's really hard to get to that data, and also way beyond what we aimed for. I think we included this public data, which GitHub is providing there, but also more to see. I mean, one of the reasons we put that in is more as an indicator how, to say bluntly, how many other projects depend on that. So if you depend on a project and the only one using that, chances that someone will fix it if there's a problem is quite low compared to a project like curl where you have millions of dependents, or the log4j case.
All right, thanks. I will hand over.
Yes, we have other two questions, but he raised the hand for you, sorry.
Hello, thank you for the talk. I'm an ex-Bosch employee, so therefore I want to be a little critical with my former employee.
Sure.
Here, we also work together in the same building. So therefore, when I was there, I also, let's say, in our project, profited massively from open source. And you also said, okay, how you can, let's say, detect risks and so on. And it's a little bit weird to see from a company which makes 2 billion in profit last year to say we need public funding despite their business case really depends on open source. I know it's not your fault in the end. It's like something where I think we as developers has to stick together and say, no, we go not for public funding, you pay it. If you don't pay them, for instance, and sustainable software, and especially sustainable open source software, means that the maintainer can make a living, can continue maintaining the software in the end. And let's say OSS funding is set up like, okay, Bosch receives some funding, so therefore some employees, let's say, will dedicate work on a specific open source project, but the maintainer doesn't see a dime from this. Well, therefore, this is a perspective I would like to see changed, for instance. And it's like a call from my side that we all work together and say, talk to the manager and say, no, this is just absurd, making 2 billion is profit, and say, okay, no, the public scene has to fund this project because our life depends on it, or let's say our product depends on it, but we can't pay for it.
I see where this argument is coming from, thanks. Maybe a quick question, I guess you refer also to this last question here. I don't want to correct there, but there's a particular reason I didn't put public in here, just funding mechanisms, because I'm also thinking that this funding, that's my personal view, it's not like, forget about the logo in the corner now, is that we need a funding mechanism which goes beyond public funding, but also private funding. And I think one step towards that goal is to first of all have the transparency that there is a problem in the supply chain. If you just say that, imagine you go to a manager who has like to lead a whole company with a lot of hardware business, so not too much software knowledge, it's another topic, and tell them, go fund open source. This is so broad, and it will be also really hard to distribute these kinds of funds. Obviously, I know it feels a bit weird to start with the distribution problem if there isn't any fund at all, first of all, but I think you kind of have to think it together, because if you really know where these funds are getting to, it's also easier to get to those. And so thanks for the input, and that's also part of why I put this question in here, because we kind of currently look into how such funding mechanisms could work or would not work, because we heard a lot of voices, a bit also what you just said, thing between the lines is, doesn't really help to have, let's say, a single grant where you just say, okay, here's, I don't know, a couple of euros, and then we have to wait or find a new grant, because then it's more like someone compared it more to, I don't want to use the word, but I don't have a better word, to do drug dealer, where you say, oh, here's some money, and now the maintainers get into a mode where they always follow this next fund, independent of whether it's a public or a private fund, more into a way also that the SDA did, where it's a bit more regularly coming in, also having the groundwork finance, like maintaining the infrastructure, who's actually maintaining the CI servers, things like that. So I think starting with the transparency is the first step here.
There is the other question before. Yes. Hi, thank you. It was very interesting. I have a question about the archetypes that you defined earlier. The archetypes mapped to the clusters that you identify with the data that you use to train your model? Okay. So if you add more data, you could be able to find more archetypes, right? Or define them?
That's a good question. It depends, I think. So, I mean, you can, it's complicated, because you can tune your clusters to basically fit in 200,000 projects into these clusters, make it more broad. But I don't think there need to be more clusters representing this data set. So maybe you can make it, so it depends on your use case. For example, if you need a really fine granular model which end up using 10 clusters, you can do that. You can tune your clustering to basically sense that.
Yeah, no, on the contrary, I was actually interested in this talk because, spoiler, I have a talk on Thursday that actually introduces score metrics that we want to use at the foundation to define project health. And this is actually very it overlaps a little bit. So instead of fine-tuning it, I would like to have like a more general overview and see if I can redefine or reuse these to redefine those archetypes based not on packages but on projects themselves.
Yes.
So yes, maybe we should discuss this
Sure. Yes.
after
Sounds
the
great,
talk.
yeah.
But I was just curious how flexible and how adaptable this
Yes.
model you use is to define these project archetypes.
So, so one last thing. You can basically make this really elastic. So, as I said, you can get a arbitrary number of clusters, but it depends what you are looking for. And the balance is that if you have a large amount of clusters, they tend to be really hard to interpret. So there's a sweet spot there. You can go with 3 clusters, but they're hard to interpret because projects sitting in these clusters are very diverse. And yeah, it's about interpretation, basically. So in this case, yeah.
Thank you.
Okay, we have one last question. Okay, that is here.
Yeah. About the dependency or the different types of dependencies. I'm not sure if you mentioned it, but you mentioned infrastructure on the previous question. So did you consider infrastructure and dependencies of the infrastructure also as a dependency of the project?
I think Sven answered the question in the beginning. The short answer is no. It's just about projects, and we haven't looked especially into dependencies of dependencies and the order of that.
Yeah, so we considered each project on its own, but not the dependency graph around the project. But it's a very, very valid point that, for instance, I really liked the presentation that I can recommend from the Airflow community, where they really looked into all of their dependencies and see and sometimes worked with that. So one of the Airflow maintainers even took over the ownership or the maintainership of one of their dependencies afterwards because they had some discussions there. So you're right, it's very valid to do that, but for now we had each as a single box, if you will, or a single project.
Okay, so we close the day now. And just an observation that if you are customized too much, maybe this is also a question to the future. If you are customized too much, maybe you are making too much selection, and there will be a doc archetype then for one single project. So yes, when she was saying it's better to have more general, so you can compare more projects and not so maybe having too much details. For closing this day, I'm happy to see you here. Tomorrow we will be here in the same room at the same time. As I mentioned to you, we have mandatory breaks, and we have another one that starts 1 minute before. That is a reception that is now going in the main room, in the main, exhibition area, so we can mingling together there, okay, with further questions for our speakers and to networking between us. So thank you all and see you tomorrow. Thank you to the speaker.